Okay, we're back and looking at a problem that combines all of it together. You have force on an angle, you have friction taking place, and this block is being dragged. I mean, we can see if I have the right pen here. It could be somebody kind of like standing like this and pulling it backwards, and the whole thing is accelerating this way. So, this is the direction of motion. Your acceleration is going to take place this way. It's an 18 kilogram block being pulled backwards like so. It's being yanked with a force. But it's being pulled on a force of 75 newtons up at an angle of 42 degrees. And you know what happens. This is going to take pressure off the surface. It's going to create less friction because you don't have as much pressure between the object and the surface. And then it'll be easier to accelerate. I mean, there's a kind of like a balance. You don't want to pull straight up because you're not going to end up, like accelerating to the right. But a little bit of lifting force is probably going to be more efficient. It kind of depends on just how much friction is involved here. But what we can do is number one, figure out the normal force. And when you look at the normal force, you're going to have to look at the vertical forces. That's what we're dealing with first. The vertical forces. We look at this. Oh, by the way, I can do this on the diagram. This is 75 cos 42, and this is 75 sine 42. So I can do that right away, as you just saw. I don't have to think. I don't have to guess whether it's sine, cos, or tan. It's always the same. So here's our vertical free body diagram. Going up, we've got the 75 sine 42. I'm going to calculate that. It's 50.2. So 50.2, and then obviously we have the normal force is also going up. And going down, we have the force of gravity. And because the vertical forces, the acceleration is 0 in the vertical direction, we can do this. The Fn plus 50.2 equals, right, your mg is the force of gravity. The normal force is going to be mg minus 50.2, which is 18 times 9.81 minus 50.2. 18 times 9.81 equals 177 minus 50.2. And I get 127. Round it off there. 127 newtons is the normal force. Now, here's the thing. Once you know the normal force and the mu, now the question doesn't ask you for this, but we need to know it. The force of friction here is 0.24 times 127 newtons. Remember what I was telling you during the lab? That means that the force of friction is 24% the normal force. So what's 24% of 127? 0.24 times 127, it's 30.5. So here the force of friction is 30.5 newtons. That's 24% of the normal force. And I didn't give myself much room to work, but I think I can handle it. So now let's go back, and to find the acceleration, B, we're looking for the horizontal forces. I'm going to draw kind of like a division here. And I'm just going to work down here. So that's the horizontal. And here the acceleration is not 0. We're actually accelerating sideways. Here's what our free body diagram will look like. We're pulling with 75 cos 42. 55.7. 55.7 newtons. And resisting is 30.5. Okay, so this is the force of friction. And this is 75 cos 42. So now I've got, like I'm doing this there's two separate free body diagrams. One is required just to get the normal force, and then from the normal force to friction. And then I have a horizontal free body diagram in order to find out the acceleration in the horizontal direction. So now my F net is going to be 55.7 minus 30.5. F net is MA. We get 25.2. That's the net force. And the acceleration is 25.2 all over the mass, which is 18. And so we divide that by 18 and we get 1.4. 1.4 meters per second squared. There you go. Number 7 is the same kind of question. The only difference is this time, for whatever reason, it's being dragged. It's being dragged down. So maybe this is like on a flat surface and somebody is down here. Maybe there's like a high platform and somebody's down here and they're right down on the floor and they're pulling it and they're trying to get it to go sideways. So the acceleration is going to be in this direction, like that. And backing up and pulling and accelerating this forwards that way. So that's how I think of it. In this case, if there's a string attached here, you've got no choice but to pull it on a downward angle. Well, let's have a look. Actually, let me change the color here. I'm going to break that 22 newtons down into its two components. This will be 22 cos 27, and this will be, not much room to work there, 22 sine 27. And I'm looking for the Fn, which means I'm going to be looking at things in the vertical plane. Here's my free body diagram. Going up is only the normal force. Going down is the force of gravity, which in this case is 14.7. And going down is also whatever 22 sine 27 is. And I get 9.99. So this is 9.99 newtons. So there is no acceleration in the vertical direction, which means that the Fn is equal to the weight, 14.7, plus 9.99 newtons. Here you're pulling down into the surface. You're increasing the normal force. This part is the weight. And this is the 22 sine 27. So here the normal force is going to be 14.7 plus 9.99 equals 24.7. And that means that the force of friction, I don't see, the mu did not come out, but I think the intention was, it's the same mu as up here. It's 0.24. And I don't know why that has disappeared. I thought that was in the diagram, but here your mu is 0.24. Let's assume that's 3 digits. That should have been in the diagram, but that's my fault. Let's go back there. So you know that the force of friction is mu k, that should be a k, kinetic, times Fn. So the force of friction will be 0.24, 24% of 24.7. And it comes out to 5.93. So that's our friction force. In the second part, we're looking for the acceleration, and that's happening horizontally. Here the A is not 0. We actually have an acceleration. Going in this way, we have 22 cos 27, which is 19.6. And back in the other direction, we have 5.93. So this is the force of friction, and this is 22 cos 27. Now our free body diagram is just going to be this. 19.6 minus 5.93. The F net is 19.6 minus 5.93, 13.7. The F net is MA. So that means the acceleration is 13.7 all over 1.5. That's the mass. You always replace the F net by MA. That's Newton's second law. Right? Your F net is MA. That's the most fundamental equation in physics right there. F net equals MA. But it also equals right forces minus left forces. It also equals up forces minus down forces. You know, there's more than one way to get it. 13.7 divided by 1.5, 9.13 meters per second squared. So that's the acceleration of this system. That acceleration might only take place for a moment, but it is necessary to know sometimes. And that's the end of that problem. We have the normal force. Yeah, and I don't know why I forgot to put in the coefficient of friction here. I mean, it even says friction. So that was the intention, but the mu got left out. And that ends that sheet. So these are the notes to kind of train you how to do these problems. My goodness, that looks crazy when you look at it all together. It's a lot of stuff. But this is going to allow you to do the assignment, which is a sheet almost identical to this one. That's going to be handed out after these notes have been gone through. All right.